Okay, we are going to record this class.
Yes! Is there a recording right now?
Yes.
Hello.
Come on, let's see. Come on.
What? You need a flash drive.
We need to finish. We need to finish early.
No, we need to.
Go home.
No, because I'm going to allow you to earn points back on your test.
Okay. Finish early. Finish early.
But you got to do it by the end of this period.
What?
Don't worry.
You want me to sit in the back? Mr. Park? Would that be better?
He's like, 1 more minute. And then I'm like, oh no, the name.
You're wasting time. You're wasting time. Yes, we're videotaping. You guys didn't touch that table, right? No. Wait, you didn't touch the table and move the thing.
No.
It's very sensitive.
I did.
Just like me, I'm sensitive.
Did you?
Okay,
Is it because
this next unit is only going to cover 2 sections, 4.4 and 4.6. We're going to spend 3 nights on this one and 3 nights on 4.6. So whatever the homework is in the assignment sheet, I'm going to split it up into 3 nights now. So I think it comes out to like
2 problems a night?
6 problems a night. Is it? I don't know, whatever it is.
Oh wait, is this the word problem?
Yeah, these are all word problems.
J.
So on the test, on the next test, which is next, is it? No, it's going to be after Thanksgiving.
Plan double C.
You're going to have 3 problems from this section and 3 problems from 4.6. So the next test is 6 problems again. You guys don't seem to do well on those.
No.
Because then some of you made like a massive error, you get -12, that's why. But then see, if you make an error, you got to finish the problem, but then you guys don't finish it. That's why, so don't make mistakes.
Bonus points. Finish early. Finish early.
Anyway, that first problem,
Finish early.
okay, let's do 2 examples. First example, let's say you have a barn. Okay, this is the side of a barn. Now, the problems that you're going to see in this section, you've seen it in Algebra 2, you've seen it in pre-calculus. It's the same word problems, except in pre-calculus last year, we used our calculator to calculate the max and min, remember? But now we're going to use calculus to calculate the max and min. Okay, so you guys remember this problem? You have a barn. Put that thing down. Here's the side of a barn. You have 120 feet of fencing available. Okay? What you want to do, is we want to make a rectangular enclosure that looks like this. And then we want to put a divider in like this because we have goats and sheep. And we want to keep them separated. We got to separate the goats from the sheep, that's why. Okay?
Like the sheeps.
So, how should I construct this enclosure to enclose the maximum area? Okay, so we're not going to use fence over here because that's the side of a barn, right? We don't need to put fence there. So we're going to put fence here, 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 and here. I have 120 feet of fencing available. How should I construct this so that the area of this enclosure is a maximum? So what we got to do is, what are we trying to maximize or minimize in this problem?
Length times width.
The area. What volume? This is not 3-dimensional. Didn't I just say, how should I construct this to maximize the area? We're trying to maximize the area. So what we need to do is we need to write the area as a function so that we can take the derivative and make a number line. See, all the problems we had before, the function was given, right? Now you have to write the function. And then you're going to do exactly the same thing. Take the derivative, make. Some of you, your number lines are still not you guys don't label the number line. You don't even write the thing underneath it. How many people didn't even do that? Oh my goodness.
Oh, yeah.
I thought we were trained already. Okay, so first define, what do you want to call X? Do you want to call X these 3 things here, or you want to call it one of these, or you want to call it the whole thing?
L and W.
I mean, it doesn't matter, okay? Let's call this X. And then what do you want to call this? Y? Now, looking at this picture, what is the area of this enclosure?
X times
X times y, right? It's a rectangle, so length times width. But the problem here is there's two variables. We only know how to take the derivative when there's one variable, right? If you want to take the derivative with two variables, then you can take multivariable calculus. That's third semester calculus. We're not there yet. So what we need to do is we need to write another equation to get rid of one of these variables. And that comes from here. There's 120 feet of fencing available. So look at this picture. What represents the amount of fencing I'm going to use? 3x plus y got to equal 120. 3x plus y equal 120. That's your other equation. Solve for one of the variables in this equation, plug it in here, and then now we got just a function of one variable. Which variable do you want to solve for?
Y.
Okay, so y equals 120 minus 3x. Take that and plug it in there, and then you get x times 120 minus 3x. So now we have a function for the area, and it's only one variable. How do you find the maximum area?
Product rule. Oh wait, no.
Well, yes, although some of you didn't use product rule yesterday, and that's a problem. I cannot believe. No, I was going to tell you guys that if it's a product, you got to use product rule, and then some of you not even multiplying by the derivative of box multiple times. Oh my goodness. Okay, if I were me, I wouldn't use product rule here. I would multiply this up. 120x minus 3x squared. I think it's just easier like that. So if I want to find when the area is going to be a maximum, take the derivative and make the number line. Okay, what's the derivative? 120 minus 6x. Factor it. I can factor out a 6, right? 20 minus x. Okay, now, I told you guys what to put on the number line. Number line labeled. If you don't have this label, it's not there on the AT exam. What do I put on the number line? What makes it 0? 20. What is that for? I'm taping it. You don't need to take notes.
Oh, okay, sorry. Here you go.
Think of a number bigger than 20, like 30. Plug it in, it comes out minus. This one comes in plus. So what? And some of you don't even write the underneath thing. A is increasing. You guys even have the legend up there, but you still don't write anything in. A is decreasing. Okay, so looking at this picture, what can I say when x is 20? Is that a maximum, a minimum, or neither?
Maximum.
It's a maximum because the thing goes up and then down. That's why you have to have this to determine whether the critical point is a max, a min, or neither. In this case, it's a max. So we say that x max is equal to 20. In other words, if I want a maximum area, I'm going to make x 20. So how should I build this enclosure? Make this 20 feet, this is 20 feet, this is 20 feet, and what should I make y? Well, go back to this one. If x is 20, 3 times 20 is 60, 120 minus 60 is 60. So y would be 60. And that's how you build this enclosure if you want to enclose maximum area.
That's the hardest it's going to get.
And if you have pets, isn't that what you want? To have maximum area? No, I'm serious because look, if you have 120 feet of fencing, you could have done this. You could have gone 1, 1, 1, and then 117. But the area is so small. The animals can't run around, right? They just have a strip. That's all they can. And if you have multiple, all they can do is this, right? Okay, now this is an example of an easy problem.
Chances are.
Let us do a medium problem. Now, in your book, the problem tonight's homework, you know, I think there's one medium one, but they're mostly all easy. Then they're going to get tougher as we go along now. So that's why you got to keep up. Shh. Okay, here is a sphere. The radius of the sphere is, give me a number.
7.
5.
Okay, 5. 5 then.
5.
The radius of this sphere is 5 units, whatever it is, okay? Inside this sphere, I am going to inscribe a right circular cylinder like this. You remember this problem from last year?
Yes.
Now there's lots of ways of putting a cylinder inside a sphere, right? You can make it like this, or you can make it like a pixie stick like this. But then, or you could make it really wide and flat, like a poker chip. But how do I put it inside the sphere so that it has maximum volume? Because the volume of this and this is not that big, right? So how do I enclose the cylinder in here so that we have maximum volume? Okay, so what are we trying to maximize in this problem? The volume of the cylinder. So what you have to do is write the volume of the cylinder as a function of one variable. Okay, so first of all, I'm assuming we know the formulas for cones, spheres, and cylinders, right?
Why would you assume that?
Because we did this in the review at the beginning of the year. Okay, now what do you want to call the radius?
Theta.
Okay. Before we even start, let's just do.
Rho.
What is the formula for volume of the cylinder? Pi r squared h. Come on, it's a prism. It's the area of the base times the height. Area of a circle times the height. Okay, now, last year, when we did this problem, how do I draw in the radius to help me do this problem? Yeah, you draw it over here like this. The radius of the sphere right there, pi. You draw that in because, ooh, there's a right triangle there. Now think. Give me my candy. Give me my
Wait,
candy.
can I take you?
Wait, is that yours?
7 is the surfing size.
Okay, just for that. Rossi de Leon. Rossi de Leon. Okay, think ahead.
No, don't.
Which one do I label X? Should I label this X or that X? Think. You gotta have foresight there.
That.
Oh, wait, this one. This one.
Yes.
Wrong.
Okay, the
You
other
want
side.
this one X.
Okay.
And remember this now because
Because you squared the other side.
this problem is gonna one more time. That's it. Okay, the reason why you want to make this X because if you use the Pythagorean theorem, what's this side going to be? Well, we did this in the review. Square root of 25 minus x squared. Now, if you did it the other way, if you label this one x, then that would be the square root of 25 minus x squared. But why do you want this one to be the radical one?
You square it.
Because you're going to square it. Okay. Here we go. Volume is pi. Now look at this picture. What's the radius? What's the radius of this cylinder? Isn't it this? Square root of 25 minus x squared. Squared, the radical disappears, times the height. What would the height of this cylinder be? Look, if that's half the height, and the whole height is 2x. Whereas if you did it the other way, okay, some of you just don't see it, yeah? What if you did it the other way? What if you called this one x, and this one root 25 minus x squared? Then the radius would be x. That's nice, Mr. Park. Yeah, but then the height would be 2 radical this. Now, which one is easier to take the derivative of? That one or that one? This one, right? Yeah. So that's why. You got to remember what I'm showing you here, because not only does it work for this one, but you're going to have cones inside like that. And then, in fact, you're going to have cylinders inside cones. I'm just warning you what you're going to have on the homework. Okay? So simplify. 2 pi x.
Spheres inside spheres.
Louis. Okay, there you go. See, it's a polynomial. Polynomials are the easiest functions to take derivatives of. Whereas you have radical, then you're going to use product rule. And some of you, as you demonstrated yesterday, you just can't take derivatives with radical. Okay, now watch. Should I distribute this 2 by x? Okay, you know what? I'm just going to tell you what to do. Watch this. When you take derivatives, you can always throw the constant on the side like an unwanted pet, right? So you see this 2 pi? I just throw it on the side already and just distribute the x part. 25x minus x cubed. I mean, it's up to you. If you want to distribute the 2 pi in, you can, but you're going to end up factoring it out anyway when you make the number line, right? So I'm just factoring it out in the beginning. So now when I take the derivative, see, throw the constant on the side. What's the derivative of this? 25 minus 3x squared. Who picked 5 as the radius? That was a bad number.
Who said that?
Because now it's not going to come out nice. See, if you picked like 6 or 3, that would have been nice, but 5 is a bad one. That's okay, no, we're not going to change it, we're going to leave it. Okay, now we are ready for the number line. Woo! This is the derivative. Okay, what are the critical values? What makes this derivative 0? I think we can do this in our head. Plus or minus
5 over radical
5 over root 3.
5
You can, okay, if you cannot do that in your head, go on the side. When is 25 minus 3x squared equal to 0? When 25 is equal to 3x squared. That's when x squared equals 25 over 3. That's when x equals plus or minus 5 over root 3. Okay, whatever. Okay, think of a number bigger than 5 over root 3.
17.
Okay, 17. If you plug that in, it's going to be negative, right? Because this one is way bigger than this one. Right? Plug in 0. And then, can you see that this problem doesn't even make sense? This problem only makes sense when x is between 0 and 5, right? Can you see that this length has to be, obviously got to be greater than 0 because you can't have negative, but it also has to be smaller than 5?
Yes.
So the domain of this problem is only between 0 and 5, so you really don't even need to test that. He is increasing. Who brought those darn pixie sticks?
Do you want another one?
Yes. Does everybody understand we don't really care what's here?
Yeah.
Because this problem only makes sense between 0 and 5. So, if I want a maximum volume, what should I make x? So we say x max is 5 over root 3. Now, once you get this, Chen, you got to answer the question. Okay? Because they can ask the question, they might say, find the dimensions of this cylinder that will maximize the volume. Or they might ask you, what is the maximum volume? So once you get this thing, you got to answer the question. So what if I were to tell you, what are the dimensions of the cylinder? What does dimensions mean in a cylinder? The radius and the height, right? So what would the radius be then? Here's the radius right here. Well, once we figured out x, how do you figure out this radius right there? You got to plug it into this. So you get the square root of 25 minus that thing squared, which is 25 over 3. Simplify that.
Can't do this.
Make a least common denominator. 75 minus 25, so that's root 50 over 3. Do I have to do everything?
Yes.
25 comes out as a 5, and you get 2, 3. So I will take that. 5. In fact, you know what? You guys are so dopey. I will take root 50 over 3. And then what about the height? What's the height of the cylinder? Well, if this is x, then isn't the height just 2x?
Yeah.
So what's 2 times that? 10 over root 3. Okay, so I did 2 examples for you. I'm serious, you guys gotta practice this. Because it's so easy. I mean, I can do every problem on the board, which is probably what's gonna happen. I've been teaching this course for 25 years, and pretty much that's what happens. But if you want to do well in the test, you guys gotta learn how to do this on your own, you know. Okay, let me pass out the test.
Oh no. Wait, what are the corrections for?
To earn more points.
No, but like, do you get all the points back?
No, you're not gonna get all the points back.